Grab. Place. Swap. Pick. Drop. Done.
Processing pipeline. This pipeline's goal is to take a photo and return the position in the robot's task space and the color of a ball. We have a camera with a Z direction down towards the checkerboard, but it's a fisheye camera, so we can see parts outside our workspace, which is wrong. We need a static mask.
Down here in the reef, I use a static mask to mark my workspace, like mapping my coral territory. I detect the checkerboard points, find their min and max X and Y, then use Poly2 mask to build a perfect boundary. Everything outside gets...
We have our workspace clear. We need to apply a color mask on each ball to sort them. Today, the red ball is the lucky winner. We can do this by using the MATLAB Image Thresholder app, where we take a photo, then, for each color, adjust the color wheel to account for only one color. We then adjust the saturation to get rid of darker values and change the value in order to have a mask that only shows the red ball. Mask for all the colors, we need to find the XY coordinates of the ball. I will have now a couple of my friends explain how we detected centroids, then corrected
To find where each color lives, I make a color mask, clean it with Boyer Open, and fill in holes, just like sweeping my tide pool clean. Then Region Props tells me where the biggest blob lives, giving me the centroid, the heart of the color.
Well, if we can detect the centroids, that's good. But we still have a problem. The ball isn't flat on the checkerboard. It's floating a bit because of its height, the Z offset. We have to correct for that.
First, we calculate the base distance, B, the direct path from the camera to the detected centroid, the foundation upon which all correction depends. B equals the square root of X squared.
Now we compute B, the correction scaled by the camera's height. A perfect balance. Geometry and precision in the service of progress.
At last, we shift X and Y along the true direction, compensating for the ball's height. The centroid is now perfectly aligned. Ha! Yes, precisely in works.
The centroid correction is perfect.
Precision at last.
For the advancement of all mankind.
Mission complete.
As my friends mentioned, we use region props to find the center of the largest object, and then use trigonometry to solve for the correction offset. We can get the correct XY position of the ball. We have to transform that into the robot's XYZ coordinate plane. We do this by first transforming from the camera to the checkerboard through offsets and rotations. Then we transform again from the checkerboard frame to the base frame. This is all done through our function image_2_robot.
When I convert image points to robot coordinates, it's like sliding from one ice patch to another. I use a rotation matrix R to realign the axes, flipping X and Y and adjusting Z. Then I add offsets, like waddling a few steps north.
Transforming from the image to the robot frame is all about reference points. I start with the pixel coordinates, map them to world space with points to world, add Z equals 0 for the flat board, then rotate and offset the results.
The time we have been waiting for! Sort balls! This function we use a while loop to continuously take photos, pass it through our image pipeline which masks the image by color, and if a ball exists, returns its position, which we then pass on to a function in robot that does the inverse kinematics, then moves to that ball in space. It then sorts the balls by color, putting them in their own boxes.